All right, as promised, here is problem number 9 on page 40 of PACE 1115. All right, let's see. I'm going to grab the PACE here and see, walk through all the things they tell us are true. Okay, circle O. And it says that OE is perpendicular to CD. All right, so that is the shortest distance from this chord to the center, that line right there. And then we have OF, right? OF is perpendicular to AB, so that means that's the shortest distance between this chord and the center. Then it says that AE is congruent to AF. Now I might not have drawn that perfectly, okay, but that length is supposedly exactly the same as that length. So in the PACE they drew it a little more carefully, but we can mark it that way and indicate those two sides are equal. Now look, they also give us one more piece of information, but it's down here in step number 2. They tell us that OA is congruent to OA. So that's this line is congruent to this line. Cool. Okay, what is that? How do we know that? How do we know that anything is congruent to itself? Remember from way back in like the second PACE, it starts with an R, right? So now we are going to, well, remember my point is we want to work from the end. So we're trying to figure out, this is what they want us to prove. They want us to prove that AB is greater than CD. The length of AB is longer than the length of CD. And I did not, yeah, so that line's that chord, okay, so this chord is greater. Well, I could say that they're greater if I know for sure that this length is less than this length. Okay, because that would mean that it's closer, and we actually have a theorem, that tells us that. But how can I say that this is shorter than this? OF is shorter than OE. So if I can somehow say that OF is less than OE, then I can make that statement, okay? But how do I get there? Well, I had to kind of go back. This is going further back as even before the last checkup, back in the earlier section. Go back to Theorem 74, okay? This is called the hinge theorem. Let's see if this one applies. If two sides of one triangle are congruent to two sides of another triangle, but the included angles, 1 and 2 here, are not congruent, then the triangle that has the larger included angle has the longer third side. So going back here to page 40, OE, so we know this is, oops, I'm looking at the wrong one. Oh, they do tell us. Do they tell us that these angles are different? Yes, I forgot to mention that. So they do tell us here in the given that measure of angle 1 is greater than the measure of angle 2. So basically, you look at Theorem 74, we've met all the requirements. We have two sides of this triangle congruent to two sides of this one. This angle is greater than this angle. And because I know that's true, I can therefore say that this OE is greater than, did I do that backwards? I did that backwards. Oh my goodness. OE is greater than OF. Whew. I'm glad you caught that. Thank you. Whew. Somebody was giving me evil eye there, and I caught it before we stopped the video. OE is greater than OF. All right. And we just looked it up, Theorem 74, so you write out, a brief statement, you can abbreviate it a little bit. then that should lead you to using, and I'm not going to tell you which one, it's a recent theorem that now that these two are proven that this one's longer than this one, the short one determines that this is closer and therefore a longer chord. All right, I hope that helps. And again, I can't always promise I can be Johnny on the spot to quickly make a video, but I appreciate when you give me feedback of where you're hitting trouble spots, and then we can work on some videos to help other students, even if I'm a little late. Maybe getting the video recorded for you, you're helping future generations, maybe some of your siblings who are coming up through geometry in future years. And you'll be giving them a help, okay? So let me know if there are other really difficult sections, and we'll do our best to create some videos and post them at pacesuccess.net. All right.